Okay, so once again, a minimum spanning tree, a minimum weight of connected graph with no cycles. There's our strategy. Now let's have a look at it. So there's a graph. There are weights, 4, 8, 11, 8, 7, 1, so on and so forth on each of the edges. And we have the nodes denoted by bigger numbers. What we're looking for is a minimum spanning tree across that graph. There may be multiple minimum spanning trees here, and they'll be determined by where you start. And your start point is arbitrary, so you can pick it yourself. I'm going to start at 0, and here's how it works. We're starting at the node 0, and what you need to do is take a look at the smallest weight connected to that. It's the 4, isn't it? We'll draw a line between the two. Now we have two nodes that we can take from, 0 and 1. We look at the smallest edge or the smallest weight connected to those. Now there are two 8s here. You can pick whichever one you want. I'm going to pick that one. Now we have 3 nodes. And what you need to do is pick the smallest weighted edge connected to those. And it's the one between 2 and 8. Now we have 4 nodes. You repeat the idea. We pick the smallest weighted edge connected between those. It's the 6. We connect the smallest weighted edge connected to those nodes. It's the 1. Smallest weighted edge connected to those nodes. And now we've got an interesting situation here. We need to connect the smallest weighted edge connected to those nodes. But if we pick the 4, we'll have a cycle between nodes 2, 6 and 5. So we need to ignore the 4 so that we don't get a cycle. In which case we go to the next highest number, which is 7. Now between nodes 7, 8 and 6 there's a 7, but if we connect that up we'd get a cycle as well, so we're going to ignore that. We're going to take the edge between 2 and 3. So we still have a tree, but we don't have any cycles. Actually, the definition of a tree is that it has no cycles, so that's kind of a moot statement. All right, again, the only one that isn't connected here is the 4, and we need to pick the lowest weighting to connect it, which is that. Now, in terms of displaying your answer, that's one way of displaying your answer, but I'd also like you to display it as with set notation. So the order that we went was 0, 1, 2, 8, 6, 7, 5, 3, 4. And the great thing about this is you can check whether all of these are connected visually in the top part and also numerically with the set notation at the end. Okay, that's my example. I'll post a video for you guys and some work for you guys to do as well.